Hey, Bobby here with Coder Foundry, and several weeks ago on social media, asked for you guys to send me coding challenges, things you're seeing during the interview process, because I wanted to see kind of what students are facing. And I got sent one that I really liked. I thought it was really cool. Let me show you the coding challenge, and then we're going to break into the code and actually solve it here. And I've also got a repo for you so that you can go ahead and try it yourself. It's all free out here on GitHub. So let me show you what we're going to do today. And this was called the Find the Missing Digit, a coding challenge. And it's simply described as you are given a simple equation. However, one digit in the equation has been replaced by a question mark, and figure out which digit, 0 through 9, should replace the question mark to make the equation correct. He gives us a couple of rules here. The equation only contains one question mark. And it always replaces a singular digit. We have to support operations like plus, minus, multiplication, and division. And the equation will always be in this format: number, operator, number, result. No number should have a leading 0. Division is integer division, and you can never divide by 0. And the answer must be a single digit from 0 to 9, and return -1 if no valid digit makes it the equation true. So you can see here, it gives us a sample here, and it's 1 question mark plus 2335. Our output should be 2 because 12 plus 23 equals 35. And same goes for these cases. The other thing that we have to do is write a function called find missing digit. And if you look at the coding challenge platforms like HackerRank or CoderByte, typically they have tests that go along with that. So you've got to tell it which function that the test can call. And so you have to follow that pattern. All right. Other than that, let's look at the code here and see what we can do. Now, what I have put together here is a repo that you can download, and the link is in the description below. And it'll have this complete solution that we're getting ready to code up. And you can see here, if we go through it, it has a program CS, and this is the entry to our C# program. And it's going to call missing digit here, and missing digit is where all of our coding takes place. And this right here, this method right here, is being called by our test unit. You can see here, it's calling all of our tests right here. And that's why we have to make use of this function name here, because this is what our test unit does. It's got testing built in. So if I right click and run all tests, you'll see here that, let's see what happens here. Something should fail. And they did. 5 failed, 2 passed, and that's because some of these return a -1, and this one returns a -1, but none of these other ones pass, okay? So we need to write our code in here to be able to look at this expression. So let's put a comment here what our expression could look like. And we'll go a test one here. And this is what one of the expressions come in. So if we run this program CS here, we've got this set up as our default in here. And then if you run tests, we have a bunch of other ones that come in here. All right. And so the first thing we want to do is replace this question mark with the available digits. Okay. So if we look at this equation here, what our expected output should be 2. And when we replace each one, it's going to look like this. So we can say 12, this would be our correct answer, equals 35. So we're trying to loop over this and replacing this digit here with values 0 through 9. So we have to test 0 through 9. And for each question in the expression, which will only have 1, okay? So the first thing that we could do here is let's write a loop. And we'll start at 0, and then it'll be I less than 10, I plus plus, and right here. Okay. All right, so we're going to loop over this from 0 to 9, and that's kind of what our loop does. And then what we want to do is for each iteration of that, we want to create a new expression by replacing the question mark with our number. So we can write a candidate. And what we're going to do is we're going to turn these into strings. So we're going to use the string method here. And makes it a little simpler to do. All right, so what this will do, candidate. All right, and then after we get each one of these, what we want to do is check if the candidate expression is valid. And we could write some code that looks like this. All right, and so we could say is valid, and we pass in the candidate, and we'll return 1 if it's valid. Else, it's going to loop to the next one and then return a -1 if it gets through all iterations here without getting a true out of our valid function here. So one of the things that we can do here is I'm going to write another method to help it here. So we'll say public static void, actually Boolean, and we'll say is valid, and we'll give a string expression. All right, let's get rid of this code here. Copilot was determined to give us something, but we're not ready for that yet. All right, so in this case, our expression is going to look like with one of the numbers in here. So we can just say it could be something like this, it could be this, it could be this. All right, and so we have to evaluate these numbers here to see if that equals this result here. So that's kind of the goal of this. So the first thing we need to do is identify what is the first thing we need to do. Our step 1. What is our step 1 in any kind of coding challenge? Is to break this part in its parts. So I'm going to create a string array parts, and I'm going to split it. And I'm going to split it on space. Because I was told in my instructions I could kind of rely on this format here. All right, so we know that when this comes in, the question mark's already been replaced by the time we get here. And if I do this, it will split it into 13 plus 23, an equal sign, and the result 35 in this case, right? So we can also make sure that we split options, and then we'll trim entries in case we need to do that. Okay. And it's just 1 there. All right. So this will give us the parts for each of them. Now here's where we need to be very careful, and we're going to call this defensive coding, is we need to check if all the parts are there. So we can just check the length here. If, and we'll say parts dot length is not equal to 5. I mean, it could be less than 5, it could be greater than 5. It's not equal to 5. This expression is invalid, so we're just going to return false. So we no longer need to be in here. The next thing we can do is we can start getting the different parts and storing them, okay? So I can go string left string equals part 0, and this is the left side of that equation. So remember, this is an array, so we get to array by indexes, and so this will bring out, in this case here, it would bring out 13 because we split on space, so the space is between them. All right, then we can also get the right side string, and let's get the operator next. Part 1, so this is the operator string. And then this is the right string here. So if this starts at 0, this is 0, 1, and 2. Copilot told us 4, but it's wrong, so we'll hit that with 2. And then I need the equality sign, the equal sign. And that'll be in the third position. And finally, I can get the results string. And that's in the fourth position. So remember, array started 0, 1, 2, 3, 4, 5. So now we have all of our parts. And one of the things that we can do now is do some more defensive coding now that we've got this to figure out if this equation is valid. The first thing we can check for to see is if the equal string is not equal to equal. All right, so if this has some other character in it right here, maybe like H or greater than or whatever it is, that is not the format we expect. And so we're going to say that this has to be equals. And if there's anything else, this equation is invalid. Okay, so we're going to do that. The next thing that we can do is one of the problems that we had, if we go back and look in here, is leading zeros. And so you have to look at all of the valid problems or edge cases here, and they give it to us and say no number should have a leading zero, meaning 03 isn't valid. Okay, so we need to write a method to verify that our numbers are valid numbers according to the constraints we have. Okay, so I'm going to write a quick other method here, and we'll say, let's see, private static bool, and we're going to say has leading 0, and we'll pass it a string. All right. All right, so if this has a leading 0, which means if it's greater length than 1, meaning it's not 0, it has double 0, and the first character in that string is 0 in the first position, then it has a leading 0, okay? So now we can check all of our strings here. So I'd say if has leading 0, left string or right string or result string, if any of those have a leading 0, we're going to return false. Leading zeros are not allowed. Okay. The next thing we can do is we need to parse our numbers. And so we need to make sure that the values that we think are numbers are actually numbers, and we need to actually turn them into integers so that we can do our math. All right. So I'm going to try parse the left string. So I wrote a quick if statement here. If try parse, and we'll call this number, right number, result number. All right. If any of those are not integers, return false. Okay, pretty simple. We can put this on one line here and make it look a little different. Right, something like that. Or we can just do it. It's fine. Let's make sure this is not as well. Okay. And so this should return false if any of these are not an integer. Okay, so that means that if we have some kind of funky character in here like this, then it wouldn't be an integer. Okay, so we can do that. The other way we could write this, if it helps you, is we could do it like this. We could put this all in one line. And maybe this will make it seem a little more readable. Sometimes I like doing that, even though it's technically more code to write. You can do it either way, however you want to do it. Okay, and so this may be a little bit more readable, instead of that or statement. So I've got two examples how you could structure this code. All right, just see how it could be done. And so now that we know that they're numbers, so if we get down to here, we have valid numbers. So now we need to know what type of math we need to do. We need to check on the operator. And if it's a plus, we need to add. If it's a minus, we need to subtract, division, multiply, etc. So what we can do is we can check that string with a switch. And one of the cool things in C# is a switch expression. And this is pretty nifty. It basically says, hey, if this is plus, then add these two numbers together and then check to see if they equal this number. So this is an expression here that evaluates to true or false, just like the method that our property returns. Okay, so our public static bool here, our method returns Boolean. And this is a return statement here in front of this case or switch statement here, operator, string, switch. Pretty nifty. Okay, it's a nifty line of code here. We also can say if the right number is not equal to 0 and this equals to this result number, return true. But one of these could happen. Okay, else if any of these aren't true or we have some other weird case in there, it's just an invalid operator. So that is our entire code here. That should do everything that we need to do. Okay, so let's step through it. Let's set a breakpoint and let's look at it in the debugger. And I think this will help you understand what's going on here. So this is our entry point. This is where the expression comes from. And then we come in here, it should just start up right in here. So let's run this and see if it works. Okay, so it's in here. So the first time we zip through this, you can see, let's add this to watch, and this one, let's clear out, and then add this to watch. All right, you can see the first time through we have a 10 plus 23 equals 35. So we can do the math in our head. This should return -1 because this is equal to 33. So we can step in our isValid function here and we can start looking at the different things that come back. And so we could look at this, we can add this to watch. And we can look at the parts in here and you can see part 0 is 10 plus 23 equals 35. So that worked exactly like we thought. And I can step over this, boom, boom, boom. And now I'm getting each of these string variables I have. And then I can look at my equality string or my equal string. It says, hey, is that equal to this character? And it is. So this thing will evaluate to true, so it won't return. We can look at the leading zeros here. None of those do, so this should step over that. And then we can try to parse it. Well, these are numbers, so they should parse. Boom, boom, boom. And now we can step into here and it looks at the operator. So our operator string is the plus sign. And so now it can evaluate this. So it can say 10 plus 23, does that equal 35? The answer is no. So it's going to return false. And when it returns, it comes back to our loop here, gets the next number. And now you can see we stopped in here. Okay, let's step in again. And then we get the next one. Boom, boom. So now we're on 1. Okay, so we start at 0, got a 1. And that is 11, 23, 35. All right, so that should step out. All right, and look, it did. It did not return because that means it came back false. And so let's look at the true scenario here. Our candidate is 12 plus 23 plus 35. So that should work. Let's step in and look at it. So if we step over, we see getting our parts here. Boom, boom, boom. Step over, step over, step over, step over. And now it's going to evaluate to plus, and then it's going to evaluate this expression. And that is true. So look what happens here. We come out. And now this is going to return true. So it's going to return a 1. Boom. And now our program exits. And you can look at the console here if you run this in C#, and you can see the program CS printed this out. The missing digit in the expression, whatever, is 2, and that's accurate. Okay. Well, there's other things that we could do as well. We can actually run our unit test now. So I can go here and run tests and make sure it passes. Now, when you're on CoderByte or HackerRank, you absolutely will have to make sure that all your tests pass. And so I'm going to come over here, run all tests, and all 7 passed. Kind of cool. And you can come over here and look and see what the tests were, and you can follow this pattern here and make your own tests. And put 20 here if you want to. All right, so that is the coding challenge, the missing digit. What I would suggest is if you are looking at this code is blank it out and try to code it yourself without, even if you look at this first, the video first, try to see if you can code it from memory, see if you can solve it and solve the problems, and then start practicing these coding challenges on a daily basis. That'll help you get more comfortable doing this on the interviews, all right? But if you need some help, you want to learn more about code, go to learn.coderfoundry.com. We'd love to be your teacher, your coach, or a mentor to get you that first job or maybe the next one. We've got courses designed for all skill levels. Anyway, I hope this helps. Good luck and keep coding.